Welcome to Thoughts and Discourses on Digital Transformation. Dive into a world of insightful conversations and profound ideas. Join us as we explore the latest trends, challenges, and opportunities in the digital age. Stay tuned for engaging discussions and expert opinions that will inspire and inform.
Okay, everyone, welcome back to another Thoughts and Discourses on Digital Transformation. And here today, I've got a very exciting guest, Basilis. I've known Basilis for a bit of time, and so he's working on a new project. So we want to go over what he's building. It's using some really cool GenAI technology. So, Basilis, you want to introduce yourself? And give us some insight on what you're doing today.
Hello everyone, thank you Colin for having me. So I'm into the internet world for over 17 years now. Gone from different positions, from web design up to web development, product management, business development, and so on. And I used some of my blood and sweater money to start doing some real estate in Greece, and I understood while I was building projects that there is a lot of space to make construction a more AI place. So try to put much more intelligence, AI, all these cool new products that the cool kids wants to play with, into an area that it's not so much deep into, and that's AI. So what I have done is I took construction materials where an architect, a simple person, a user who wants to renovate their building, their home, a constructor, anyone who is looking for materials, they have so many choices that it's really hard to find what you are looking for. And even for an architect, let's say for example, who is designing a 3D space, it's hard to find the materials they need. For a constructor, it's hard to find what a project requirement has inside, and find the tiles, find the wood for the kitchen, and so on. So what I'm doing here is I'm building a brain, I'm building an embedded model, I'm building an agent that allows users to find materials through hundreds of databases that we are feeding into that knowledge base.
So that seems a huge market, right? So it seems always like you're trying to boil the ocean because there's so many different materials, even if you just pick a house, right? So is there a certain area that you're going to focus on initially and then broaden it out?
Correct. We are starting first with tiles, which is a little bit easier to find exactly what you need, because if we take, for example, wood, one oak is a little bit similar with another oak, so it's going to be different to identify them. But on tiles, there are specific patterns on the digital prints that exist on each tile that allows us to separate them a little bit. So we start with tiles, and the more that the training is happening, the more that we have more success rate, the easier we'll get afterwards to other materials.
Okay, and so can you walk through, right? You get tile data, right? It's probably in a whole bunch of different formats. It might be PDFs, it might be Excel, it might be just a website, it might be paper. What are you doing to process that so it'll be easier to understand for people searching for tile and tile data?
So we start by importing PDFs that the factories are providing to us. Those PDFs have from an image up to different details like the name of the tile, size that the tile is available for, format, square, rectangle, and so on, thickness, finishes, colors, patterns, what's the usage for the tile, is either wall, floor, application area, it's inside or outside, indoor or outdoor, a general look that we say, and there are some other technical specifications that come like R rating, surface type, edge type, if it's fire resistance or not, frost resistance or not, what's the water absorption, rectified type of series, what's their packing, and so on. So we get all these kind of details that allows us to organize our model and then start training it, because our focus is not to only train it for the image, but with all the details that the tile has. And then when we get an input for the user, that let's say we get a prompt that says I need a cement type tile for outdoors, then that allows us to serve to them the specific results.
Yeah, and what part of GenAI, what libraries and what tools are you using to do all of this work?
So we have Python-based libraries. Of course, we're using PyTorch, we're using Tensor for the training and for the recognitions. We are exploring right now a little bit of a hybrid system that will allow us to import not only from the OCR system that we have built, but also try new libraries like recognition of documents that Microsoft is providing. We also are doing a research if what Google is providing makes sense. We try to have a hybrid system here, Colin, that uses both our internal but also external projects. And what we are doing is we are ranking what we get, so basically the input, and based on the AI ranking that we are doing, if from one system the input is better from the other system, we keep this one. So we are trying to also internally build another knowledge base that allows to understand which one of the inputs is better, and then based on the ranking that we give to the system, we provide we use that results for our knowledge base and for our internal training.
Right. And then what tools are you using to actually develop this when you're writing code, right? Are you using any of the GenAI tools? If so, which one and why?
Cool. So we started by building it by hand. We tried different type of tools. We have tried Windsurf. We have tried Augmented, which is part of all these GenAI methods. We have tried and we made ourselves a lot familiar with RooCode. RooCode is something that works on top of Visual Composer, and it has methodologies that allows you to also build the project the right way. So put the product requirement inside, orchestrate it, create the architecture, and then start building the code following some specific methodologies. We also have enhanced it, and we made it to work based on how we want the system to be built, and we are using it a lot to try to help speed up the time. Of course, there are parts like ML training that those tools are not so much familiar with, and there we have to develop what we need to put in place.
And how much faster do you think you are using these new tools versus, you mentioned hand coding or developing it yourself? Are you 5 times faster, 10% faster? What do you think you are?
So it helps a lot. It has brought down the time by half, and by integrating, by enhancing those tools, like I told you, we are using RooCode with RooCommander. It's an open package you can find at GitHub that allows you to enhance RooCode and make your life much easier. It brings the time even to 3 times down. You can get it faster if you want, but it needs a little bit some other models like Context 7, for example, that you need to integrate also this one and loop it in a way that you make sure that the code output is the best possible. From me, if you ask me, I'm impressed of how much you can use those tools to get results. I started before we work on Kai on this. There is another project that we're working together, No Code API. There, we build no-code forms from ground up by only using those kind of tools, by only using AI coding. No user hand has put in place to actually produce no-code forms. So I believe that the more you are using those tools, the more familiar you get with, the more you learn how to use them correctly, because of course even that requires training. It's like prompting, it's the same kind of thing. The more those tools get familiar with you and they learn how you explain things, how you format things, the better results you can get, the faster you can get into coding the results you need.
And when do you think your first release of this tile-based solution, Kai, is going to be ready?
So the system right now it's in a really, really good phase. We are just doing some code review and we are preparing the last steps for us to actually fix the last bugs and deploy it. We estimate that in the next month we will have a working model of the application, and then we will be having a month to finalize all the training that we are doing, because the training is the hard part. Here, to give you an explanation, we started with stable diffusion for us to generate 3D models, and we noticed that this is not the best output when it comes to 3D modeling. And we had to switch to stable diffusion Excel base 1 as a model, and now we are retraining for us on how to get the actual best results for making an architect model. So there are changes that are happening because technology is changing so fast when it comes to GenAI models that we have to change things also as we move. PeerTouch has changed 5 times from when we started building, so even the retraining is getting different, which help us get better results. I'm not complaining, right? But at the end of the day, you have to put not only money but your energy and training resources in place that makes things a little bit harder.
Yeah, and I think that's one of the big things that people don't talk about is the training of the models, right? I think people just use the baseline models and expect magic results. But really the reality is, just like with any machine learning behind the scenes, right? Training of the models to fine tune them to get the results is absolutely a critical piece of that. So how much energy are you actually spending training the models or updating the new model, any of the models? Give me an idea of the effort and how much time and how much data do you need to train these models?
So right now, I'm sorry I'm using this application for the first time, but let me share my screen if that's okay with you.
Sure, yeah.
And we have used almost a data set of 12K cement related tiles, so we can train as much as we can. This AI accuracy that we see, of course, it's not good. Why? Because our data set is small, right? So on a small data set, of course, your accuracy is going to be good. But when it comes to having a RAG search, and I do here cement tiles, and our system goes and generates the tiles that exist right now in our platform, the result is that we can see a lot of details about a specific tile based on the training and what we have done. As you can see, even because we are focused on those kind of specific data sets, okay, we get just those results, nothing else. Okay, if we go although to the collections that we create for our tiles, or yes, let's go to collections. If you go to collections, you can see that we used here for a collection the porcelain floor tiles, and the system can't understand completely what's happening. Or when I request a marble countertop, it went and took from just the coffee table the marble countertop, that it's not a countertop. Basically the floor was the countertop. So when I created this for our presentation here, just so we can understand that you need a lot of training for the system to understand when you are talking for a marble countertop that you need the material to be an actual countertop of marble, porcelain one. But
Right.
Here the system identified that the coffee table, which is a solid HPL panel that has the look of a marble top, it's the marble top that it's porcelain one. So of course this one we have to remove it from the library, Why? Because we need to define that this one doesn't belong to this, and then we have to retrain the model to remove all these HPL panels. So we mark it as something that is wrong. And of
So
course,
it's very iterative. So what you're doing is very iterative, and it seems like a manual process to validate,
of
you know,
course.
the
So
work.
when we train it on something specific, let's say cement-based tiles, the first models, the first catalogs, I also review them myself. The more that I remove something, or the more that I press that it's accurate on the training, the more it understands, it gets a better feeling as a model, and then the next ones it doesn't do so many mistakes. And that's why we have many
Right.
models in place. We have the one that does the image clarification, we have the one that does the material detection, one that does the tile recognition, one that understands the features that a tile has, because I can show you here, for example. So I can show you here that these are all features of a tile, right? So even for those calling, we try to match them in between. So the AI can understand that if a customer wants a cement tile and they pick this one for their tile, for their cart, sorry, and they want to get also alternative solutions, the alternative suggestions needs to match all those. It can't be an alternative that is a different size, for example, right? Because the customer picked 120 by 60. So when we upload a photo of an architect and we tell the system, we tell the agent, find me that material, then it needs to understand that the 3D design has a 100 by 60, and it needs to return tiles that are only 120 by 60.
Right. Okay, so that's really cool. So, you know, this demo that you're showing, right? You know, how long did it take to create this? You know, is this several months of work, or
So what I
what
did
is
is
it?
that I decided which one of the material UIs I want to use, and I sent afterwards I took all our requirements, all our documentation. Actually, that's also something cool that I would like you to see, and maybe in one call we don't have time to show everything to people, but at the end of the day we can.
Yeah, we'll end up doing multiple
Yeah, but
calls, right?
let me share you also our documentation, so people can understand. Screen again. So this is our documentation, right? It's a starting point of what we have in place, and every single item that we are developing, we are keeping complete track of what we are building. At the end of the day,
Right.
coming to OCR, material recognition, types, supported material types, everything. So what we do every time that we update this, we ask AI to update our we ask AI to update our UI with the new things that we are adding in place based on the documentation. That allows us to build a really nice system that keeps track of what's happening and automatically update the UI front end with the new API endpoints that we have added it, with details on how we want to work because we have it on the documentation. So AI at this stage is building our front end without us having to do any front end work anymore.
Okay. So that's really cool, right? Okay, well, we're about out of time, so thanks, Basilis. I look forward to having another discussion when you're further along with this, and maybe we can have a more detailed explanation of how you did the training and how well it's going.
Happy to do
Okay,
it, Oliver. Thank you
thanks.
very much.
Bye.